All right, welcome everyone. On behalf of RST Automation and Beyond Clean, I'm so glad you joined us today for this webinar. My name is Lindsay Braun from the Beyond Clean team, and as you probably already know, parts of the average sterile processing department already include some kind of automation. But what about all those other dangerous, boring, or overly complex tasks that sterile processing technicians struggle to complete on a daily basis? The technology that helps us solve those challenges already exists. And I'm so excited because on this Vendor Spotlight webinar, we are going to learn about the AIM tray assembly system from RST Automation's very own Braun Kiess. With over 13 years of experience in a diverse range of industries, Mr. Kiess regularly consults to Fortune 500 companies and IP-based startups on valuation. He sits on multiple corporate boards and is an adjunct professor of finance at Rutgers Business School. I'm so excited to learn more from Braun today, and I hope all of you are too. So without further ado, I will turn it over to Braun.
Hi, thanks so much, Lindsay. Good morning, everyone. I hope you're all doing well. It's my pleasure to be joining you to talk a little bit about RST and about the innovative products we've been bringing to market. So I'm just going to jump right in here with a little bit of background on RST. So we were founded back in 2014, and our focus has really been to develop products that enhance the safety, efficiency, and effectiveness of the sterile processing department. So we're really focused on being a leader in automation systems, and our technologies, we hope, as you'll see, I think position us to do that. So I wanted to start off by just giving you a little bit of overview on our technology. So all of our products, which I'll introduce to you shortly, really center around our core technologies, which is a combination of machine vision and artificial intelligence. And by combining those two, it gives us the ability to automatically recognize instruments. So it gives us this automatic instrument identification. So we are able to our systems are able to optically recognize instruments without using any forms of barcoding or RFID or any sort of instrument identification. So they're able to just optically recognize them without any modification. We currently have three products. Our first product that we introduced, and the product I'm going to be talking to you about today, is called AIM Tray Assembly. AIM Tray Assembly was created to help technicians assemble trays more accurately and more efficiently. We also have a product called AIM Storage. AIM Storage was created to help facilities better manage their excess instrument inventory. So it helps you know what instruments you have in inventory and where they're located. And then our newest product, which is AIM Peel Pack, was created to help technicians assemble peel pouches more consistently and more efficiently. But today we're going to be talking about our first product, which was AIM Tray Assembly. And this system, again, was created to just help technicians assemble trays more efficiently and more accurately. And as we'll see, it has a number of features that we think really helps technicians do their job better. But before I dive into the specifics on that product, I just wanted to sort of zoom out here to kind of a 30,000-foot view and sort of talk to you a little bit about what led to kind of the inspiration for tray assembly. And what we saw when we looked, and our team has a lot of experience in the sterile processing department. We spent a lot of time observing technicians in the department. And what we saw when we looked, and when we spoke to managers of these departments and observed what was going on inside them, is really, a process with regards to tray assembly that is a very error-prone process. It's a very labor-intensive process. What we find in the departments is that a lot of times this labor isn't available. So, what we find across the country, sterile processing departments are consistently understaffed. And a lot of times the labor isn't adequately trained either. So there tends to be a pretty high turnover rate in a lot of facilities with respect to technicians. So a lot of times the techs just don't have the experience or the certifications that they need to really, assemble these trays correctly. And as we know, right, the sterile processing department is, of course, a critical supply, right, center to the operating rooms. If there's errors in these trays, if these trays are incomplete or incorrect, that can cause, right, delays in the operating rooms. It can cause, right, upset surgeons, and in worst case scenarios, right, it can affect patient safety. So it's very important that this job be done correctly and accurately. We also want to make sure, right, that the counts are always accurate because that'll help eliminate, right, the a chance that instruments are left inside of patients. And just from a data perspective, right, we see that it's really hard to for managers of the department to get accurate data about their tray assembly process. So all these were sort of the high-level problems that we identified when looking at, right, the current methods that are used to assemble trays in the sterile processing environment. Specifically, right, we actually identified 10 problems in surgical tray assembly. First problem was we saw a lot of wasted time in the process. So there's a lot of time spent by technicians, sorting, right, instrumentation. So typically, right, first thing a technician do is they'll walk up to their workstation with a tray of instruments. They'll dump that, right, tray out onto the workstation, and then they'll start sort of sorting, right, like instruments with like instruments. Well, that whole process takes a lot of time, that sort of pre-sorting. In addition, there's really no consistency in this process. So as an example, if you have 20 technicians assembling the same tray, chances are they do that 20 different ways. Obviously, from a process perspective, not what we want to see. Actually, the only thing consistently that we did find when looking at the tray assembly process is what we referred to as air counting. And this is something we've seen almost every technician do in every facility we've been in. And what this involves is the technicians, right, they take their tray of instruments over to the workstation, they dump them out, they start pre-sorting them. Now they're supposed to be, right, checking those instruments off on whatever instrument management software they're using one by one, right? As they identify them, inspect them, test them, place them in, right, place them back in the basket, they're supposed to be checking those instruments off individually, one at a time. That never happens. What we see technicians doing instead is they keep the count in their head. So they process the tray of instruments, they sort of pre-sort them, and then they start sort of, right, getting their counts together in their head. They realize they're missing something. They leave the workstation. They come back. They keep assembling the tray. Again, this whole time, right, keeping that count in their head. And then at the end, right, when they believe the tray to be complete, they then, right, go onto the software, right, onto their computer screen and check off everything in rapid succession. Again, from a process perspective, you can see how that would be a very error-prone process and not one that we're looking for. So we also see some inspection issues. So technicians are often inspecting several instruments at a time, right? They're supposed to be inspecting and testing them one at a time, but instead you'll often find them picking up, right, 5 or 6 or 7 or more looped instruments at once and sort of spreading them open, flipping them over, right? Doing that, doing those multiple instruments at the same time. Again, just from a process perspective, right, not what we want to see. Also a lot of wasted hand motion. So between the pre-sorting and then the inspection and testing and then the assembly of the stringers, there's a lot of wasted hand motion. Strung instruments especially are being handled multiple times. So again, just a lot of wasted motion and fatigue there. A lot of wasted time. Again, more wasted time we see in the retrieval of missing instruments. So, right, technicians, as they're sort of assembling this tray, they realize that they're missing something and they leave, they retrieve that instrument, then they come back, they keep assembling the tray, they realize they're missing another instrument, they leave, right, and then come back. And this back and forth, right, creates a lot of wasted time and potential, right, diversions in the tray assembly process. Bottlenecks are something we also often observe, especially when you're training new employees or you have large complex trays with maybe 150 instruments or more, right, that need to be assembled, but there's perhaps nobody, right, or very few people who have the experience and knowledge to properly assemble that tray. Well, that creates a bottleneck, right, in the department where that one person now, right, has to handle, right, all these complex trays. Volume and quality issues, something we see pretty regularly, right? The norm is that the later shifts typically tend to get more of the volume, and that makes them and the staff on those shifts much more vulnerable to fatigue-related quality issues. And we've seen directly, right, being able to tie tray errors to how long the employee's been working, how long the technician's been on their shift. As they get to the end of the shift, they're tired or perhaps they're working a double shift, and we see clearly a spike in tray errors, right, the later into the shift we get. Too many tasks. In general, the technicians, right, they have to do a lot at once with tray assembly. So not only do they have to be identifying and sort of counting the instrumentation, but they also need to be inspecting and testing it and assembling the stringers, which Again, it's just a lot of things to be doing simultaneously, and helps, we believe, lead to a higher than necessary error rate. Bad data, this just is sort of more on the management side of things, but again, it's existing instrument management software, just existing tray tracking systems are typically very challenged in the data that they're able to produce as far as tray assembly times and technician performance. So, and the reason for that is that these systems are just really too dependent on the technician for the data reporting. So, right, the data is all driven by when the tray gets scanned in and scanned out, and that's something that technicians tend to do very inconsistently. So our solution to these problems, right, was what we call AIM tray assembly. AIM, by the way, stands for Assisted Instrument Management, and that's currently all of our three current products all fall in our sort of AIM family of systems. And our first product, as I mentioned, was tray assembly, which we believe really represents a real innovation in sterile processing. So I thought I'd just play a little clip for you here to give you an overview of the system.
In healthcare, there is constant pressure to deliver more with less. To meet the challenge, all kinds of tasks are being reimagined, but the instrument assembly process has been overlooked so far. Why are we handling instruments multiple times? Why do we risk human error, such as misidentified instruments or incomplete surgical kits? Why are we inspecting handfuls of instruments at once or verifying count sheets with as many as 150 instruments from memory? We can aim higher. The Assisted Instrument Management System, AIM, from RST Automation revolutionizes central sterile processing methods in a number of ways. It heightens the quality of the process itself by reducing costly errors. It improves technician accountability. It accelerates technician training, making new technicians knowledgeable, faster, and more accurate in a much shorter period of time. It speeds the process to increase productivity and allow more time for instrument inspection. The AIM system. AIM plugs into any standard 110-volt outlet and is housed in a compact mobile cart. The AIM system is portable and fits virtually anywhere. Roll it out, plug it in, and it's ready to go. The touchscreen features a user interface that is quick to learn and easy to use. From the home screen, technicians can assemble a tray or interact with the system's training module. Powerful optical recognition algorithms identify each instrument without instrument modification. As each instrument is recognized, AIM software automatically validates the count sheet. At any time, techs can reference stored instrument images or review a list of instruments needed to complete the tray. AIM works as a standalone system, or it can seamlessly interface with instrument management software. A badge and tray scan initiates the assembly process. The AIM system accepts instruments in random order. All looped instruments are collected, counted, and sorted into the proper order inside the machine, allowing for easy transfer to a stringer. Non-looped instruments are identified, counted, and returned to the technician for proper placement in the tray. AIM instructs the technician about where the instrument should be placed. Techs quickly establish a seamless, easy rhythm that can significantly reduce the time for tray assembly. Instruments are handled fewer times and staff can focus on quality, ensuring that each instrument is free of contamination and working properly. Missing instruments are reported to the technician at the end of the tray assembly process. An optional printer add-on is available. This allows technicians to retrieve all missing instruments in one convenient step. AIM can be interfaced with automated storage systems for rapid instrument retrieval. When automated sorting and inspection is complete, technicians remove the pre-sorted looped instruments for stringing. It's simple, it's fast, and it's safe. The AIM system requires minimal instruction to use, and its instrument training mode gets users up to speed quickly with minimal oversight. In training mode, a variety of visual cues help users recognize mistakes and learn instrumentation. With AIM, inexperienced techs can quickly become as productive as your veteran techs. Cloud-based reporting provides extensive data and graphs for tracking and improving technician performance. This type of accurate instrument-level data has never before been available. From training to the final process, AIM is the smart system for your Sterile Processing Department. AIM for improved process quality. AIM for faster and easier technician training. AIM for better technician accountability. AIM for increased productivity. Achieve sterile processing excellence with AIM. Call now to learn what AIM can do for you.
So again, just to sort of highlight some of the features of the system. So again, AIM tray assembly is a system that optically recognizes the surgical instruments without modification. It'll verify their quantities on the count sheet. It will assemble all the looped instrumentation for the technician. So it'll assemble those stringers for the techs. It does have a training and education module that helps train and educate your technicians on the instrumentation. And it'll interface with any instrument management software that you're currently using. So some additional features, as you saw in the video, at any point the technician can just press a button to get a list of all the instruments that are needed to complete the tray. So if, say, at the end of the tray assembly process, the tech has processed all the instruments they have, but the tray is still incomplete, they can just hit the needed button on the screen and then print that list of missing instruments and go retrieve those instruments all at the same time. We actually have also interfaced this system with our AIM storage system and also with Henel storage system. So I can actually send jobs to the storage system or to the Henel units and make that instrument retrieval even easier. On the little list it prints out, it can also we can also incorporate the location of the instruments. So if you're using bins or drawers or Henel systems, well, if you're using a Henel system, it will send the job to that system. But if you're using bins or drawers and don't have one of our AIM storage units, it can then we can just associate, a drawer or a bin number with that instrument to help the technician retrieve it even easier. And the important thing is they can do it all right in one step. So instead of that back and forth we see currently in tray assembly, they can do that as one step at the end of the process. The system does maintain a very accurate and very granular log of instrument by instrument handling data. So we know exactly how long it takes to process every instrument in that tray, and as well as, of course, the overall tray assembly time. So we have very granular reporting data. We can run, there's a lot of different ways we can slice and dice that data. We can tell, again, the time to process every instrument in the tray, the time, of course, for the overall tray, the time between trays, and we can see, what instruments might be taking more time to process and then sort of find out why that's happening. We can identify what instruments are commonly missing and place those perhaps closer to the workstation or in an easier to access location. So there's a lot of great data that's created by the system that really helps manage the process. And again, this data is not dependent on the technician. So unlike the data you're currently getting out of your instrument management software, this data is not really technician dependent. So it's independently accurate, or what we like to call very actionable data. AIM, of course, tray assembly does inform the technician about any incorrect or missing instruments. So if the technician, for example, had an instrument that did not belong in the tray they were assembling, if they were to place that instrument into our system, it would kick it back, It would say, nope, that instrument's not needed, doesn't belong in this tray. If the count's full and they try and put another instrument in there, it'll of course tell them, hey, no, count's full, don't need any more of these, And of course, if the tray is not complete, then they know that it's not complete, and they're not able to close it out until it's complete. So it really helps from a quality perspective in those areas. And as I've mentioned, it does, of course, interface with any instrument management systems or rotary storage systems out there. So just a quick survey for everyone who's joined us this morning. Just curious to know what instrument management software you use. So if you could just take a minute and just respond to this poll as to what software you use, if any. And just make sure you scroll down. So if you just scroll down, you should at the bottom see your submit button, and just be sure to select a choice and then hit that submit button. Just give everybody here a minute to complete that. Okay, let's see. We should have some results coming in now. All right, so it looks like over half, or almost half of the folks use Microsystems SPM, 12.5% use SensaTrack, 6.3% Abacus, 12.5% Impress, 12.5% no tracking system, and 12.5% other. So great. Thank you so much. Just, always interested to know, right, what software is being used out there and how prevalent it is in the department. So let's talk a little bit about the benefits that AIM tray assembly delivers. And the benefits that AIM tray assembly delivers really fall into three categories. So AIM tray assembly has both operational, clinical, and financial benefits for your department. First, let's talk about, and we'll talk a little bit about each one. Let's talk about the operational benefits first. So this slide here just shows sort of the process flow for tray assembly before AIM, right, before using tray assembly, and then the process flow without AIM. And as you can see, right, AIM tray assembly sort of makes the process much simpler, right? It handles a lot of steps in that process flow for the technician. So it's a simpler process, it's a structured process, right, and it's a very error-free process. Specifically, the operational benefits from the system fall into three categories. So first and foremost, right, it's really all about process quality. So, right, it's all about delivering a quality product up to the operating room. And that's first and foremost, we think what the system does is really improve the process quality. Secondly is really all about the technician, right? So it really helps with technician accountability and also with the training and education of your technicians. And then, of course, last but not least are the productivity benefits, so the throughput increase we see in, right, just the ability to process trays more efficiently. Let's talk a little bit about each one of those categories. So improved process quality, what we think that tray assembly does most importantly, perhaps, is that it fundamentally just structures this unstructured process, right? So as I mentioned before, if you had 20 techs assembling, right, the same tray, likely, chances are they're doing it 20 different ways currently. So now if they assemble the tray in our system, everybody is assembling the tray the same way. So for the first time, we now have a consistent, right, tray assembly process. And for those of you who are involved in process improvement at all, you'll know that consistency is kind of the first step in achieving process excellence. So we have now fundamentally a structured process. This process we also feel is just a better quality process in the sense that, what I like to say is, look, there's things that machines do well and there's things that humans do well. And what we should be doing is, allow the machines to do the things that they do well, which then allows the humans to focus more on the things that they do well. And sort of by combining the two, right, we get the optimal, right, sort of the optimal outcome. So in using tray assembly, what this does is it allows the technician to really focus on inspection and testing. And inspection and testing are critical, right? It's a critical component of the tray assembly process. It's a component that is very, very difficult or impossible for a machine to do. But it's very important for the technician to do. So tray assembly allows the technicians to focus more on the testing and inspection of the instrumentation, because the system is handling the identification, the counting, the sorting, and the assembly of those stringers for the technician. So by sort of taking over those jobs, it allows the technicians to focus more on their high-value jobs. We also feel the system facilitates individual instrument inspection, which is an important thing, right? So before, as I mentioned, when you would see the technicians inspecting multiple instruments at the same time, now the instruments are handled one at a time because they're fed into the system one at a time. So because of that, they're picking instruments up individually, they're processing them individually, and they're hence inspecting and testing them individually, which again is just to feel a higher quality process. We also, of course, eliminate defects too. So, it's not going to make all of your trays perfect. It doesn't eliminate every type of error, but the system does eliminate missing instrument errors, incorrect stringer order, errors. It really gets rid of that error counting that we see so commonly in the tray assembly process, as for a large part being a source of a lot of these errors. And of course, we know when we have complete and correct trays, that makes surgeons happy and hopefully prevents any operating room delays. So So these categories, right, again, missing instrumentation, incorrect stringer order are virtually eliminated by the system. Because remember, the nice thing about machines is, right, they don't get tired, they don't get fatigued, they don't make mistakes, right? So the system's never tired. It's always identifying the instruments, identifying them accurately, and identifying them consistently. And because of that, right, we see, the elimination of these types of errors. So this is some actual customer data from a facility that employs our systems, a customer of ours. They had roughly, and this is a missing instrument, so this is the error rate pertaining to missing instruments in the trays. They had a 3.5% error rate before implementing AIM. And afterwards, that dropped to 0%. So, and we're talking millions of instruments. So, this facility processed, this is over the course of the year, they processed just under 1 million instruments on the system. And again, there were 0 errors in the trays associated with, right, those 1 million instruments. So, again, it's a number we're really proud of, and we think really shows, right, the effect that the system can have on quality. Another side effect is, right, the incorrect instrumentation too, right? So if you find there's incorrect instrumentation getting in your trays, right, techs are putting in the wrong size instruments or just playing the incorrect instruments, it'll catch that, right? It'll catch that and it'll force them to put the correct instrumentation in there. So again, just another opportunity to get to know you and your facility a little more. How many operating rooms, right? So this is another poll question. How many operating rooms does your sterile processing department serve? Less than 5, 5 to 10, 10 to 20, right? More than 20. Again, and I don't think you need to scroll on this one. The submit button should be, right, visible there. So if you could just go ahead and answer that poll question, we'll see the results here in a moment. Okay, great. We should see some results coming in here. Let's see. Okay, so 12.5% less than 5, 12.5% 5 to 10, 10 to 20 is 37.5%, and more than 20, another 37.5%. So great, yeah. Typically we find the higher the volume of the facility, right, the more benefit you see, and the more tray assembly systems you may need. That's something we're always happy to work with you and to determine, right, the needs of your facility. So we can look at your tray assembly volumes and the types of trays that are being assembled, and from that we can determine exactly how many systems you might need. And again, it's not that, right, if you are servicing less than 5 ORs, it's still fine. I mean, depending on what the focus is, right, how big of a focus there is on quality. Let's talk about the second operational benefit of AIM tray assembly. So the second operational benefit all really has to do with the technician. So it's all about technician accountability, right? Better technician accountability and training and education. So again, for the first time, right, AIM tray assembly really provides first-in-class data. So this is data regarding tray assembly that has never before been available. And again, we have this data on an instrument-by-instrument basis. So we know exactly how long it takes to process every instrument in the tray. And this, right, this data, and of course, right, the data that's also tells us how long it took to assemble the tray overall. We can also, again, track the time between trays, right, and we can do that on a tray type basis, on a technician basis, by date, right, any date range you want. So there's a lot of different ways we can slice and dice this data. But, right, it really, right, this type of data would help facilitate, if you wanted to get into Six Sigma type process improvement in your department, this type of data is what you need to get into, right, that type of, those types of programs. And it's also, the nice thing is, it's giving real-time feedback to the technician. So at the end of the tray assembly, right, when the tray is complete, up on the screen, the techs will see a little summary box that tells them how long it took to assemble the tray, how many instruments they did in under 10 seconds, which is sort of a benchmark we use, which I'll talk more about in a little bit. So it's giving some nice real-time feedback to the tech too, to give them a sense of, right, how good a job they're doing, or how long it took them, right, to finish the tray. The other really important thing is the training and education module. So you can put the system in what's called training mode. So it does have a training mode. And what happens when you put the system in training mode is instead of automatically identifying the instrument for the technician and checking it off on the count sheet, instead it just asks them what instrument it is. So it presents them with 4 choices. They select, right, A, B, C, or D, and then it simply keeps score, right? It keeps score of how well they're doing. And then this is this is data that's saved inside the systems. You can log in, you can review the scores. You'll hope obviously to see those scores improving over time as they learn the instrumentation. But the point is, it can really help, right, train and deliver consistent training and education. Right, to your staff. And every time they use the system, actually, it's reinforcing the instrumentation names, right? So every time they process an instrument on the system is, presenting the name of that instrument to the technician. It's highlighting that instrument on the count sheet. They can, go in and view more pictures and catalog data about the instrumentation. So it's always, right, every time they use the system, it's reinforcing, right, that instrument data or that instrument recognition. And then, of course, you can also put it into the training mode, which, right, just further reinforces that. Here's some of the tray assembly data. So this is, again, actual customer data. And this is typically what we see. So we'll see, there is sort of a learning curve, right, to the system. So, technicians just need to get used to using the system. There's sort of an efficient way as far as hand motions and things go to use the system. So it takes a little bit of time to sort of get into the rhythm, if you will, of processing trays on the system. And to some degree, the system also learns your facility's instrumentation. So there's a bit of a learning curve on both the system side and also on the technician side. But this is very typical. What we'll see is technicians usually starting to process instruments. They start off usually in the 20 to 30 second per instrument range. And then you'll see those times drop pretty significantly, right, as they become, right, more comfortable with the system and sort of learn how to use it efficiently. And you'll see them getting down to around that 10-second per instrument mark, which is really what we kind of set initially as a benchmark for the tech. So the system will actually process instruments at the rate of about 2 to 3 seconds per instrument, but that doesn't allow any time, right, for inspection and testing. So allowing a good amount of time, right, a thorough amount of time for every instrument to be inspected and testing, that's what gets us to that 10-second per instrument sort of benchmark. And again, that's a very comfortable pace. It's not a rush pace. You'll see some techs dropping below that. So really about 6 or 7 seconds per instrument is probably the optimal rate, right? Again, allowing a good amount of time for inspection and testing, but not too much time, right? Not sort of wasted time. Interestingly enough, if we actually see techs, right, if you see techs fall below about 6 seconds an instrument, they're not doing their inspection and testing. So at that point, we would actually be giving them feedback to slow down, right, to take more time, right, spend more time on these instruments, make sure, right, you're thoroughly inspecting and testing these instruments. So as you can see, you can really manage the tray assembly process here and your techs in a very granular way that really just helps, right, is really all about just helping ensure quality. Here's some more data. This is just instruments per tray versus, right, the minutes it takes to assemble the tray. And again, this is very indicative of that roughly 10-second per instrument, right, processing speed that we see. So 34 instrument trays, and again, this is actual customer data, right? So they're processing those small trays in about 6.5 minutes, right? Those big trays, 150 instrument trays, are taking about 22, 23 minutes, right? 80 instrument tray, which is pretty common with a major basket, right? It's being done in about 10 to 12 minute range, something in there. So a question for you, again, just getting to know your facility a little more. Does your facility have an educator? And you see there's a few choices, yes, no, and yes, but the position may be vacant, or no, but we're planning to hire one. So again, we find that educators really help, right, in the management and implementation of our systems. It's not necessary. I mean, we've developed training programs that, are meant to exist without, right, an educator. But if there is an educator present, right, it always helps a lot with the training, right, and implementation of our system. So I'll give everybody just a moment to answer that poll question here, and again, we'll see the results here in a few seconds. All right, so we should have some results coming in here. So it looks like about more than half the folks do have an educator, a third do not, and 13% fall into that other category. So great. Well, yeah, good to, again, just interesting data points. So let's talk about the last category of operational benefits, which has to do with productivity. This is all about really throughput, right? How many instruments can be processed by a technician in a shift. And here we generally see pretty significantly reduced tray assembly times. We feel that reduction in tray assembly time is attributable to a number of factors. One, remember we talked about that pre-sorting, right? The technician, right, if they're not using AIM tray assembly, they walk up to the workstation, they empty out their tray of instruments, they start, right, pre-sorting those instruments. Well, that whole pre-sorting, right, takes sometimes in excess of 5 minutes to do. So with AIM tray assembly, that pre-sorting is no longer required, right? The techs can just walk up with a tray of instruments and just start feeding those instruments into the system in random order, right? They no longer need to pre-sort them. The visual recognition of the system just, right, creates confidence, right? Techs aren't second guessing, right? They're not, again, air counting, keeping that count in their head and then thinking, oh, wait a minute, geez, did I screw that up? Did I count this instrument or not? Right? And then maybe having to start the tray over again, or, right, causing delays and just thinking about what they've done and haven't done. The system also eliminates a lot of that repetitive hand motion, especially with respect to strung instruments. So remember, the system is right, creating that tray, that stringer, right, of looped instruments for the technician. So there's a lot less just, handling of instruments and fatigue, right, in the handling of them. We also think we pick up a lot of time in the handling, right, the way the system handles missing instruments. So again, instead of having to, instead of the technician, as they're assembling a tray, realizing they're missing an instrument, leaving the workstation, coming back, continuing to assemble, and realize they're missing another instrument, right, leaving the workstation, coming back, continuing to assemble. Here, all the missing instruments are handled in one step at the end of the tray assembly process. So when they're done processing all the instruments in the tray, if the tray is not complete, they hit the needed button, they hit print, right? They've got then that little shopping list of missing instruments. They can then go retrieve them all at once. They also ideally have the location of those missing instruments, or perhaps that whole job is just sent over, right, to, again, our storage system or to a Hanel unit, allowing for, right, really fast and easy missing instrument retrieval. And of course, the data, right, that we're getting, it just allows for better management. So we can track time between trays, we can track, tray assembly times and performance. So, right, we can now, for the first time, really be able to, right, track the production capacity, right, of a technician. And the nice thing is that techs can be productive while learning. So remember, the system is constantly reinforcing the instrumentation names, right, to the techs. It does have that training and education mode that'll help them, right, learn the instrumentation in the tray. So what we find is that this, right, really helps onboard technicians, right, new techs a lot faster. In many cases will eliminate or greatly reduce the need for preceptors. And I mean, we have instances where we've had technicians on our systems, right? These are folks we've hired that have never seen, right, a tray of surgical instruments before. We train them on our system for a week. We train them to use AIM tray assembly. They became what we call a certified AIM tray assembly tech. And that next week, they're in the facility accurately and efficiently assembling trays that have 150 instruments in them. Right? And those 150 instrument trays, prior to AIM, right, may take a technician that had 6 months to a year, right, of experience to be able to properly assemble. And it's just mentally fatiguing for them to assemble a tray, right, of that size. So now, right, it's a much easier task. The technicians, right, are in a week versus months of training, right, are accurately, right, and efficiently assembling large trays, and with much less fatigue as well. Again, here's some actual customer data. This is just tray assembly time comparisons. So this is real data from our customers. And to get, so this is again time to assemble the tray before AIM and after AIM. Tray A was roughly about an 80 instrument tray. It was a major basket. Tray B had about 120 instruments in it, or 110. And tray C was a large tray, about 150 instruments in that tray. And the way we were able, again, our system gives us very accurate tray assembly times, from the data reporting capability. the times without AIM were not so easy to get, right? The data we often see in instrument management systems is very inaccurate. So what we did in this case is we actually, this particular department had security cameras in place throughout the department. So what we would do is we just watched all the security camera footage and would time with a stopwatch how long it was taking, right, techs to assemble, right, these various trays. And there's, of course, variations, right? This was an average of what we observed. But on average, right, tray A, again, that sort of 80 instrument major basket, was taking on average about 22 minutes to assemble before AIM. Under 10 minutes, right, 9.7 minutes with AIM. Tray B, 45 minutes was the average, down to about 16 minutes with AIM. And tray C, again, that big 150 instrument basket. Some techs would do it in 45 minutes. Others would take up to an hour and 15 minutes. But the average was about 60 minutes to assemble that tray, and again, dropped to under 20 minutes. And again, this is all with very consistent quality and a more, right, structured and better sort of quality tray assembly process. So let's now talk about the clinical benefits of AIM tray assembly. Really, right, the clinical benefits stem from the improved quality for the most part, right? So again, having accurate and complete trays, that's going to reduce, right, operating room delays. It's going to make surgeons happy, right, when they have the correct instruments in their trays and they have complete trays. And, right, we're going to reduce, hopefully, the risk of malfunctioning or contaminated instruments. So because we've now structured this process, because the technicians are now handling this instrumentation, one at a time, right, we find just an overall, it's a higher quality process that's more focused, right, on individual instrument testing, right, and inspection, which is what we want, and is really what, right, humans are so good at. So let's now talk a little bit about the financial benefits, right, of AIM tray assembly. So the financial benefits can really fall broadly into two categories here, okay? Hard cost savings and soft cost savings. The hard cost savings are what the folks in your finance department are going to care about. These are the cost savings that we can specifically tie to line items on your operating budgets. So we're talking about here reducing overtime costs, right? So again, we saw the graphs, right? The increased the reduced tray assembly times, right? So it's that reduction in tray assembly times, right? The increased throughput that we see from the use of the systems that really help reduce the labor costs in assembling, right, trays. So. And this usually comes through in either the form of reducing overtime, so less overtime costs, because oftentimes, right, the departments are understaffed to begin with, so there's a lot of overtime, right? We put our systems in place, right? The trays get done faster, more accurately, so it reduces the overtime, or just, right, less vacant positions. So now, right, there's less of a backlog. The trays are getting done, right, more efficiently, and so, right, there's, maybe you're not hiring, right, more people, or you're able to redeploy some of your staff to decontam or to another area, right, in the department that needs help. So, but we can, right, again, by analyzing your tray volumes and types of trays, we can, we have very detailed what we call ROI models, right, return on investment models that we can use to calculate what the return on investment your facility would see from the purchase or lease of our systems, and that's of course what ultimately, right, the finance folks want to see is, right, what sort of return on our investment would we get from purchasing this system, and those we can tie out very directly to the hard cost savings. And again, a lot of times the ROIs, right, the returns on investments we see are really strong. A lot of times they'll even exceed 70%. Which is a very strong return on investment. And again, that's going to be based on your specific facility, what your labor costs are, what your tray volumes are, what the tray mix is, right? So, but again, that's something we work with you to figure out and present. And then there's also the soft cost savings, which again, we can't tie to a specific number, but typically everybody will agree, right, that they exist. So, having accurate and complete trays, again, is going to reduce those OR delays. It's going to make surgeons happier. And, those, while it's hard to tie a specific dollar number to those things, right, we can all, I think, agree that there is value there too in the soft cost side. So, sort of in summary here, right? AIM tray assembly is really a proven solution to improve process quality. So we have, again, our systems have, we have many customers that have our systems. They have processed millions of instruments, right, with zero defects. The systems help provide faster and easier technician training. So you're talking about getting new techs right up and producing in a matter of weeks instead of months. And again, also, eliminating the need for preceptors. Much better technician accountability. So again, what we call sort of actionable data, right? Actionable instrument level data. So we know exactly how long it takes to process every instrument, to process every tray. Again, the time between trays, right? All that data is now available to you and is accurate. And productivity, right? So we're looking at potentially reducing tray assembly times in some cases by up to 70%. Here's just a nice testimonial from one of our customers. AIM enhances our tray assembly process and provides us with actionable data for process improvement and operational management. With AIM, we have seen significant decreases in per instrument processing times and incorrect or missing instrument errors. In fact, the thousands of trays processed using AIM have had zero missing incorrect instrument errors over the last year. AIM also helps train the staff and get them up to speed more quickly and with less oversight. Because of all this, our AIM systems have become a critical resource that we rely on every day. And that's a quote from Corey Nessman. At the time she made this quote, she was at Hospital for Special Surgery in Manhattan. Now she's over at Cedars-Sinai, the director over at Cedars-Sinai in California. So in summary, RST, right, we're an innovative technology company that's dedicated to improving, right, the Sterile Processing Department quality and workflow. Our AIM tray assembly system is a proven tool for SBDs to improve their process quality, their technician accountability, their training and education program, and their productivity. These systems can be shown to offer a very attractive return on investment for facilities, and we really look forward to working with you going forward to see how we can help you achieve excellence in sterile processing. So one last poll question. The results of this we won't make public, but are just for internal use. So would you like someone from our company to reach out to you with some additional information, either about our AIM tray assembly product or any of our other products, AIM storage or AIM peel pack? And I'll just give everyone a moment to complete this. All right, so I think we've probably had enough time to complete that question. So here's just some contact information. If anybody wants to reach out directly, happy to talk with you to learn more about the needs of your facility specifically, answer any questions you have. We can provide quotes. We can provide specifications on the system. So feel free to call. You can also text me, email. Whatever's the easiest way for you to get in contact. And with that, I think we're going to open it up for the question and A, or the Q&A portion of the presentation. So, happy to answer any questions anyone might have. Lindsay, maybe I'll turn it back over to you for a second.
Sounds good. Yes, Braun, thank you so much for providing such great information on this product. Based on the questions that have come through so far, it sounds like there's a lot of excitement and interest in learning more. So I will get right into it and ask you the first question, which is, does the technician need to place the instrument in order of the stringer?
No, they do not. So the instruments can be placed in random order, and the system will place them in the order that is on the count sheet. So again, the technician can feed them in random order, and then the system places them in the correct order.
Okay, next question. And if anyone else has questions, there is a Q&A box at the bottom left-hand side of your screen. Feel free to type in any question that you have for Braun, and we'll try to get to as many as we can in the next 11 or so minutes. The next question, Braun, how does it recognize the instruments? Will it work with all manufacturers?
Yes. AIM does not differentiate between manufacturers. So if an instrument, assuming the instruments look the same between manufacturers. So as far as our system is concerned, if the instrument looks the same, it's that instrument. It doesn't care who made it.
Okay. Next question. How does AIM technology measure data based on the complexity of the instrument tray? Is there a weighted value attributed by a super user, or does the technology make an automatic assessment based off of recognition of certain catalog numbers that are built into the algorithm?
I'm not sure if I wholly understand it, but let me take a shot at let me just reread this question. Measure data on the complexity. So to us, the complexity, right? A tray, AIM doesn't have complexity, right? It just identifies the instrument. Complexity to us is simply how many instruments are in the tray. So if you have a small tray versus a large tray, that's going to take more or less time to process. But as far as IDing the instruments, it IDs them whether they're I guess easy to identify instruments or hard to identify instruments. Again, as long as the instruments look different, then it will differentiate them. And that's sort of as far as it goes as complexity. But with regards to the data that you're getting, obviously you're going to see a tray that has more instruments, right, is what we would kind of call a more complex tray, and that would take longer to process. Does that answer that question? If not, please type in a follow-up.
Yeah. And if there is a follow-up, please feel free to submit it. Thank you so much. Next question. What is the biggest reason that a sterile processing department might not adopt your technology?
That's a great question. The biggest reason, one is probably budget. If facility just doesn't have the budget for our systems, that's sometimes a stopping point. We are pretty flexible there, right? I know, right, especially with COVID out there, a lot of capital budgets have been pared back pretty significantly. But we do offer rent programs, rental programs, rent to own programs. You can also lease the systems, lease to own programs. We also have per instrument pricing, so where facilities could pay nothing up front and basically just pay based on usage. So we would just bill them at the end of the month for based on the number of instruments processed on the system. So we're really flexible, to work around budget constraints. If you don't have the capital budget, we'll figure out a way to make this an operating expense, right, to make this part of the operating budget. And so we're flexible there. But I'd say budget's probably the number one. Besides that, it is right. It's a new way of doing things, and we find that's probably our second biggest challenge. Is when implementing new technology, you're really talking about change management, right? So we're going in and we're changing the way technicians assemble trays. And if you have techs that have been assembling a tray the same way for the last 20 or 30 years, right, we often find they're not so excited, right, to change the way they do that. And that's really where we need to work on engagement, right? We need them to understand, right, the quality benefits that are coming out of the system, and to really, tie that to, why do they need to use this system? What's the benefit, right, to the facility from using it? How does it help them do their job, better and more accurately, and ultimately with less fatigue, right? So the system, ultimately helps the technician to be less tired at the end of their shift, right? It really takes a lot of the weight of that instrument identification and counting and sorting and stringer assembly, right? That weight is now sort of lifted off of them, and they get to really just focus on inspection and testing and the other things that that are so important that they do. But I'd say that's the second biggest category would be just sort of managing the change involved with a new tray assembly process, and being able to overcome sometimes the resistance from the staff in changing the way they do things.
We talk a lot about it on the Beyond Clean team about how change is hard, and managing change is not for the light or not for the faint of heart. I'll call it.
It is. It's a big challenge.
It is, but when change is inevitable, and when it's a benefit to the overall process, it's certainly worth it. The next question that came through: how about small hospitals? Do many 1 OR hospitals use your services and your products?
You know, what happens is the answer to that question is it all depends on how focused on quality you are. You know, if the facility is going to put quality first and foremost, then yes. If they're really looking right, the problem with a low volume or a low volume facility is when it comes to that hard cost savings, when it comes to that ROI number, the numbers, if we're not putting any price on quality, then the efficiency you would see right in the production of trays at a low volume facility oftentimes won't by itself justify the purchase. But right, if the facility is willing to put a value on quality, which again really falls more on the soft cost saving side of things. We can see how much more quickly trays are being assembled and tie that to a hard cost savings. When it comes to the quality side of things, making sure that the correct instruments are in the tray and that the trays are complete and that the instruments are all functioning and don't have bioburden on them and all those types of things. There's clearly, I think we can all agree on, there's value there, but it all depends on how willing the management of the facility is to, or how much and how willing they are to put value on those sort of soft cost quality items.
Okay. Next question. Some of our instruments have QR codes. Can your product read those?
It currently cannot. It's something we'd be interested in working with you on. We've thought about putting a QR reader, in the system. So the answer to that question is currently no, but, again, it's a project we'd be interested in working with you on.
Okay, great. And you talked a little bit during your presentation about the instrument tracking systems and the compatibility of your product with some tracking systems that are out there. This question says, are you working with any instrument tracking systems? Could this product be offered through them to their customers? I guess getting toward your strategic partnerships.
Right. Yeah. So we've worked to some degree with just about every instrument management software company out there, and we're just at sort of various stages of development with all of them. So we have a very nice interface completed with Microsystems SPM software, with TDOC software, and ever SensaTrack, Impress, every sort of other software out there. We're at just kind of a various stage of interfacing or development. Thus far, they are not sort of resellers or reps of our technology. So we certainly, work hand in hand with them, and we feel we both sort of enhance each other. But right now, you would need to contact us or some of our manufacturers reps. So we do have manufacturers reps in various states. We're based out of the Bronx, so in the New York area. So we sort of ourselves handle the New York metro area, but then we have reps in various states across the country that provide local support and question answering and things like that. So yeah, if you were to reach out, if you just wanted to reach out to me, I'd be happy to point you in the right direction as to who could get you more info and provide some local support.
Okay, wonderful. The next questions, I'm going to actually loop these two questions together. The first is, how long have you been on the market? And the second is your product available internationally?
Sure. So we currently, I'll answer the second one first. We currently are not shipping internationally. We've just sort of got our hands full with everything going on in the U.S. And we're very busy here. So currently we are not handling any international sales. We get actually quite a few inquiries all the time, but we're just not able to we're just not there yet. In the coming years, I think we absolutely will be handling international sales, and we do have international patents filed and a pretty broad patent portfolio, both domestically and abroad. And with regards to, and I'm sorry, what was the first question again?
The first question was, how long have you been on the market?
Oh, how long have we been on the market? So again, we were founded back in 2014. We spent a number of years sort of in R&D, research and development and improvement on this product. So let's see. So we launched, I would say we launched tray assembly 4 years ago. which again was our first product. Our next product, AIM Storage, we launched 2 years ago, and AIM Peel Pack we just launched sort of the beta version of at the ISHM show last year, and that system just started shipping commercially here about a month ago. So 4 years, 2 years, and 1 year would be the answer to that question. And I'll also just mention we do have a upcoming webinar on our AIM Peel Pack system coming up soon too. I believe is that on the 6th, Lindsay, September 6th?
It is indeed. And actually, I'm glad you brought that up. There is a button, an icon along the bottom. It's on the bottom right. It's a call to action button. And you can actually register for the Peel Pack webinar before you even leave this webinar. So if you want more information on that system, you can certainly register today for that. Just to dovetail off of your answer to the international question, this question came through on the heels of that. What about Canada?
Canada. Canada, we actually sort of are, able to, or have been working with a few customers up there. That we are able to service Canada. So yes, I should have put an asterisk above that. If you're in Canada, we're more than happy to work with you. That is something we can handle right now.
Okay, great. We have time for one more question. Follow up. We have over 12,000 instruments. New ones are added from different vendors. How can we make sure the system will identify them?
That's what it does. So if it hasn't seen an instrument before, so of course it comes loaded with our database on it, which has seen a lot of instruments at this point. But if it comes across an instrument it's never seen before, basically it learns it. So that's and it takes a few times, a few instances for it to become confident that it's accurately recognizing the instrument. But that's sort of where the artificial intelligence comes into play. Whereas it is constantly learning instrumentation and updating its confidence, which is really just a statistical probability, right? Its confidence in the instrument that it's accurately identified it. That's what the system does. Now, I will just put a caveat on there, right? The tray assembly system wouldn't process all the trays in your department, right? So it doesn't generally do, scopes, power tool sets, right? Things of that nature. What we like to say is the system processes basically kind of the knives and forks and spoons of the department, very well. So, so the major baskets, minor baskets, right? Things like that. Are great fits for the system. Obviously, things like power tool sets, wouldn't be. But it knows a lot of instrumentation, and if it hasn't seen it, it'll learn it.
Wonderful. Thank you so much. And everyone who is tuned in this morning, thank you for joining us, or I should say today, because there are folks from all over the world tuned into this presentation. So whatever time it is, I hope you enjoy the rest of the day. Please note that on the right-hand side of your event console, you'll find a resources option. And under that resources option, there will be some downloadable resources, some product brochures, a link to the recent Vendor Spotlight podcast episode, an interview between Braun, Kiess, and Justin Poulin from the Beyond Clean team. So certainly check that out if you haven't had a chance yet. Braun's contact information and speaker information is also in the speaker bio section on the right-hand side of your screen. If you have any questions, feel free to reach out. If we didn't get to your question, know that your question will be passed along to Braun for him to address directly via email. So thank you, everyone, for your time today. Thank you, Braun, for sharing such interesting product information. And we look forward to hopefully seeing many of you back on October 6th when we talk about the Peel Pack system. Thanks, everybody. Enjoy the day.
Thanks, everybody.